Welcome to my channel today. Today we want to talk about the practical applications of exponential functions. All that we've come to learn about exponential functions, we want to apply it to, let's say, what problem under exponential functions. Okay, that's basically what this whole thing is about. All right, so without wasting much time, let's go and solve the first question. It says that the temperature T degrees Celsius of a hot drink after T minutes is made is given by this particular formula. Okay, so now the question says that find the temperature of the drink when it was made. Okay, so now this is where you want to think a little bit. Well, this particular formula comes with a T in it, where T is the minutes. Okay, so when you make that drink right there, okay, time is 0. You haven't covered time. Okay, you just made it, so we can say that T must be 0. And if T is 0, just put 0 there. So 75 e to the power negative 0.02 into brackets 0 plus 20. And then you put the whole thing on the calculator, okay? Just don't waste time that, okay, I'm going to simplify and simplify. You're just wasting time. Put the whole thing on the calculator. All right, so you have 75. Now, if you want to do a little bit of thinking, that's also fine. This time 0 is still 0. E to the power 0 is 1. So you just have 75 plus 20, giving you 95. That's just fine. Okay, so the big T is for temperature, so that you can just say 95 degrees Celsius. Okay, so that was the temperature. All right, now the next question says that find the temperature of the drink when T is what? 6. So right now, good thing for us is that they have given us the T, okay, the T when it's 6. So just put 6 there. So you have T is equal to 75 e to the power negative 0.02 into bracket 6 plus 20, okay, because they said T is 6. So we just put everything on calculator. 75 e to the power negative 0.02 into 6, all right, plus 20. According to my calculator, I should get 86.5. I could be wrong though. All right, so just check it out with your calculator. Now they said I find the value of the small t when the big T is what? 65. Okay, remember that the formula is T is equal to 75 e to the power negative 0.02 small t plus 20. Now they said that the big T is 65. So 65 is equal to what we have here. And they want us to find the value of the small t. All right, that's okay. So we just move the 20 to the other side. So 65 minus 20, we have 45 is equal to 75 e to the power negative 0.2 t. Okay, we can divide both sides by 75. And now 45 divided by 75 will give us 3/5 is equal to e to the power negative 0.02 t. All right, so in this case we can just take the length of both sides to find t. So if I take the length of both sides, or why don't I just even flip it? Okay, write it this way. I like to put the variable on my left. It makes more sense to me. Doesn't mean that when you do that you are wrong, no. So I'll take the length of both sides, and that will be what we have here is equal to length 3/5, and then we will get negative 0.02 t is equal to ln 3/5. Then I'm going to have t is equal to ln 3/5 divided by negative 0.02, and the calculator will tell me that that is 25.5. Okay, all right, now we are done, right? Good. That's according to 3SF. So this is basically how this whole thing is about. Like, it's a word problem under exponential functions. Let's see. So in this case, they said that at the beginning of 2015, the population of species of animal was estimated to be this. Okay, so that's quite interesting. Let's highlight that. This is the population of the animal as of 2015. This number decreased so that after a period of time, n is what? In years, okay? The population was this body here. Okay, what do they want? Estimate the population at the beginning of what? 2020. Well, from 2015 to 2020, that means that what is n? Well, sure, n has to be 5 because you have, gone about 5 years now. So we will have 500, actually it's about 50,000 e to the power negative 0.03, n is 5. And then let's put it on a calculator and see. So e to the power negative 0.03 to bracket 5 is going to give us 43035.39882. So this is basically like 43000 correct to 3SF, right? Okay. Now the B part says estimate the year in which, so now we are going to look for the n, okay? Estimate the year in which the population be expected to have first decreased to 5,000. Okay, so now this population should decrease to 5,000. So whatever we have should be equal to 5,000 at that time. Okay, e to the power negative 0.03 n. Okay, so this particular formula should decrease all the way to what? 5,000. We are looking for n. Well, first, the zeros will cancel out for sure. 1, 2, 3, 1, 2, 3. Okay, and then you can divide both sides by what? 50. So you have like 50 over 5. That's 1 over 10 is equal to e to the power negative 0.03 n. So you can take the ln of both sides. So you have ln. Okay, I think we can just write 0.1 at this point, which will be okay, right? Then ln this guy. So this means we have ln 0.1 is equal to negative 0.03 n. Divide both sides by that, and is equal to what you have here all over negative 0.03 n would be what? Let's put it on the calculator. Ln 0.1 divided by negative 0.03. Calculator says you have 76.75. So 3SF will give us 77 years. 77 years. Okay, that is correct to 3SF. All right, then it says the value as dollars, okay, dollars in V of a house. Now they are also telling us that the years is n. Sometimes it's t, sometimes n. So depending on the problem. What do they want? When n is 3, this is the value of V. Okay, we've heard you. They want us to find the initial value, initial important value of this house. So initial means from the beginning. Okay, so from the beginning, you haven't covered any year. So n is 0. So from the beginning, n is 0. That means that this whole thing, a to the power 0, will become 250,000. This will be the value of the house because n is 0. Now they want us to find the value of a. How do we do that? Well, they told us that when n is 3, V is this whole thing. Okay, so let's put it there. V will be 350,000 is equal to 250,000 e to the power an. But what is n? N is 3. Okay. All right, so we can do some cancellations. 1, 2, 3, 1, 2, 3, 1, 1. Okay, cancel out. We are good to go. So now we have 35 is equal to 25 e to the power 3a. Okay, divide both sides by 25. So 35 divided by 25 will give us 1.4. So 1.4 is equal to e to the power 3a. Take the ln of both sides. So you have ln 1.4 is equal to ln e to the power 3a. So that means that 3a is equal to 1 ln 1.4, and then a is basically ln 1.4 all over 3. Put that on the calculator. Okay, don't think at all. 1.4 over 3, calculator says that a should be 0.112, correct to 3SF. Okay, now what do they want? Estimate the number of years for this house to double in value. What was the initial value? The initial value is this. So if we want it to double, then we are looking at 500,000. Okay, so now 500,000 will be equal to the formula they gave us, right? This particular guy here. All right, so you have 250,000, e to the power a and right, but we know a is 0.112, and n we don't know. That's what they want us to find. So first, let the zeros cancel out. 1, 2, 3, 4. 1, 2, 3, 4. Okay, then you divide both sides by 25, giving you 2 here is equal to e to the power 0.112n. Take the ln of both sides. Ln 2 is equal to ln e to the power 0.112n, giving you ln 2 is equal to 0.112n. Divide both sides by n, you have ln 2 over 0.112. Calculator says is what? Let's see. Ln 2 over 0.112. Calculator says is 6.19. Correct to 3 significant figures. So it will take you this number of years for the house to double in value. Okay, so that's it. Right, so the next video we will talk about the graphs of exponential and logarithmic functions. Okay, so I'll give you tricks on how to sketch these graphs so that in the exam, I mean, you are very, very comfortable. So look out for this particular video on the channel in the next few hours, and you're going to get it. And if you are watching this video later than I uploaded it, then it means that the video is also available right now. All right, so in the next couple of hours, you should see this particular video over there. So this is the end of our lesson on what we call the practical applications of exponential functions, that I like to call word problem under exponential function. So basically it's word problem that we are just looking at it and then solving questions like that. If you check the May, June, and then the February papers, 2021, you will see that a couple of questions like these came. We haven't written the October, November, so I don't know, but I'm guessing that maybe a question on this will come in the paper 1 or the paper 2 or any of the papers. Okay, let's cross our fingers for our friends who are yet to write. Let's wish them all the best when a question like this drops. So till we meet again, stay safe. Bye for now.